In this video, we're going to go a little bit into molar mass and how we convert between the different values that you might see. So let's start here. I'm talking about how many moles there are in 6.60 grams of ammonium sulfate. Now, I've already calculated out the gram molecular mass for ammonium sulfate right there. So what I'm going to be doing here is I'm going to be converting that into moles. Now what I need to do is I need to use this conversion factor, but what's very important is that I need to cancel out grams of ammonium sulfate. So grams of ammonium sulfate needs to be in the denominator so that they can cancel out. 132.16 grams of ammonium sulfate is going to be 1 mole of ammonium sulfate, which is what I'm trying to get to. So I set it up like this, and now I can cancel out grams of ammonium sulfate, and what I'm left with is going to be moles of it. So 6.6 divided by 132.16 is going to work out to be 0.0499 moles of ammonium sulfate. So make sure you set up your conversion factor right there so it's going to cancel out. Next up, how many moles in 4.5 kilograms of calcium hydroxide? What's important here is that I have kilograms when I should have it in grams. So 4.5 kilograms is going to work out to be 4,500 grams of calcium hydroxide because there's going to be 1,000 grams in 1 kilogram right there. Now I can take my 4,500 grams of calcium hydroxide and use my conversion factor. I need to cancel out grams of calcium hydroxide, so grams is going to need to be in the denominator and moles is going to be in the numerator right there. When I set it up like this, I can cancel out grams and what I'm left with is moles. So 4,500 divided by 74.1 is in order to be 60.73 moles of calcium hydroxide. How many molecules are there in 25 grams of sulfuric acid? So sulfuric acid, I have the gram molecular mass calculated out there. And when we're talking molecules, I need to use Avogadro's number, 6.02 times 10 to the 23rd. That's how many particles there are going to be in 1 mole of a substance. So I'll start with my 25 grams of sulfuric acid. I need to first convert that into moles, then use my conversion factor here. 98.08 grams is going to be 1 mole of sulfuric acid. Now I need to know that 1 mole of sulfuric acid is going to be 6.02 times 10 to the 23rd molecules or particles of this particular product right here. Now I can cancel out grams, cancel out moles, and what I'm going to be left with is going to be particles or molecules of this. So doing the math right now, 25 times 6.02 times 10 to the 23rd divided by 98.08 is going to work out to be 1.53 times 10 to the 23rd molecules of sulfuric acid. How many molecules in the following? So another one like this, I start with my grams. I'm going to need to first convert that into moles using this conversion factor right here. 342.34 grams is going to be 1 mole right there. So I'm going to have to cancel that out. So I'm going to set that up for moles. Now I know that 1 mole is going to be 6.02 times 10 to the 23rd using Avogadro's number right there. Cancel out grams of sugar. Cancel out moles of sugar, and what I'm left with is going to be molecules of sugar. That's going to work out to be 2.19 times 10 to the 23rd molecules of sugar. Now, I'm asking, what is the mass in grams of 6.25 moles of copper nitrate? So I'm going to start with this, my moles of copper nitrate right there. I'm going to use the same conversion factor. This time, however, I'm going to put the number on top because I'm canceling out moles. I'm trying to get to grams. I could have it either way, but this is the only one that would actually cancel out moles of copper nitrate. Set it up here. I can cancel those out. What I'm left with is 1,172.31 grams of copper nitrate, or you could write that as 1.17 kilograms of copper nitrate. Both will give you essentially the same idea.